All right, time is up. Let's get going. Welcome everyone. Let me share my screen a minute. All right. Okay. Let me know if you can hear me. You can see my screen.
Yes.
Good to go. Okay. Welcome to introduction to Wikimania Cloud Services, free tools hosting. My name is Komala Seram Sapati. I'm a developer advocate at the foundation, focusing mainly on cloud services. If you are like me, just a year ago, I didn't know that Wikimedia has its own public cloud services that can be used by contributors for creating tools and working with the projects. So in this talk, I will take you on a tour of the public cloud platform the foundation has, and then do a bit of comparison with the well-known public clouds out there, and what you can do with what you have, and the fact that it is free for any contributor to use as long as the use case aligns with the movement's mission. So the Wikimedia Cloud Services, it's a public cloud platform that comes with a growing list of services to help contributors build tools, create bots, host code, analyze data, do your own research. And like a typical cloud platform, it comes with services for compute, storage, and even networking. And the cloud infrastructure is built with open source technology, and it's free for anyone to use as long as your use case aligns with the movement's mission. So the cloud services infrastructure and services is built by a dedicated team of professionals and a host of technical contributors around the world doing various type of work, from development to SRE work, technical support, writing documentation, and all that. So let me run through some of the numbers we have. It's a bit outdated, but still relevant. So edits to Wikipedia, with some reaching about 80%. Edits to Wikidata has tools hosted on cloud services, and some tools hosted on cloud VPS projects, with cloud instances running in like hundreds, and then ToolForge tools also has a lot of edits that are made on a lot of wikis, English wiki, French wiki, Spanish wiki, that host tools on cloud, either cloud VPS project or ToolForge project. So the numbers we have here, we have about 30.4% of total edits made to Wikimedia wikis are from bots or tools running on ToolForge. And then we have about 161 projects running on cloud VPS, and 51% of total edits made to Wikidata from tools hosted on ToolForge. And then we also have numbers of which has now become higher than what we currently have, about 2,900 tools on ToolForge and about 2,000 over 2,000 maintainers of ToolForge tools. So these technical contributions are not limited to Wikipedia or Wikidata, but all other projects around them in the Wikimedia ecosystem. So it can be used to generate reports or statistics, fix content problems, counter vandalism, automation, or just add data in batches. So I'll go through a bit of what we currently have by way of services, and then just oppose them to some of the cloud services, public cloud services you might be familiar with. So, okay, we have a Cloud VPS, which is our offering of infrastructure as a service, which you can compare to EC2 for Amazon Web Service, Compute Engine for Google Cloud, or Azure virtual machines. If you want more control of the infrastructure, this is the way to go. And we also have ToolForge, which is more or less our offering for a PaaS or a platform as a service you'll find on other public cloud, similar to Elastic Beanstalk for Amazon Web Service, or maybe even App Engine for Google Cloud, or App Service for Azure. So if you want to just write your code, deploy it, and have the infrastructure run it for you, this is the way to go. And we also have Query, which is an SQL interface for wiki replicas. Allows you to run database query to fetch data. If you're a data analyst or a researcher, or basically just experimenting, you want to experiment with Wikimedia data, this is a service you can start with. It's a good place to start. We'll look at them again later in the presentation. And then we also have POS. This is the foundation's deployment of a typical Python Jupyter notebook. Just like a typical notebook, you can execute your code in your web browser. You can share your code, experiment, or run a fly-by-night code. Yeah, so it's available to you if you're already familiar with that. That's something you can also use. So we have some other key components that you can use in tandem with tools or services you may deploy on either Cloud VPS or ToolForge or in other environments. So one key such component is ToolsDB. It is a shared database that tools can use. You can think of it as a database as a service offering. It is based on MariaDB or MySQL. Once you create your ToolForge account, your home directory comes with a config file for this. You can use to access data. And we also have wiki replicas, which are production database replicas with private data redacted. You can use for your analysis if you are researching or if you develop the tools. Basically, it's available for you to use. And then we also have DAMs, wiki test DAMs you can also use. And then for storage, we have a network file sharing based storage for your tools. So your user files are stored on this storage that are available to you from different systems. So it is a NFS based storage you can use. We have I spoke earlier about Query. It offers a web UI to run SQL queries from web browser. So so I mentioned that if you're a data analyst, a researcher, or simply just curious about Wikimedia data, this is a good place to start. Even if you want to just learn SQL, this is also a good place you can start from. Most of this is a typical query session. Most community members use it to learn SQL, to learn more about Wikimedia databases, to fetch arbitrary information, or just experiment to and then develop their own tools. Okay. Yeah, you can also use it to search queries used by previous users, and learn from the queries they run in order to fetch the data you need for your own studies or experiment or development. It's generally just a great way of learning what data is there and how to extract it. And then we have a POS, which is a recursive acronym for POS, a web shell. It's a Jupyter notebook deployment hosted by the foundation. And much like a typical notebook, it comes pre-installed with tools. You can share your code. You can run code within your browser. So there are some common tools that are used by the community members, like a Power bot framework for creating and running bots. So the Jupyter notebook comes pre-installed with that. If you don't want to install Power Wikibot framework on your local machine or on a VPS server to maintain a wiki, you can use a POS to make those changes on your wiki without actual installation. Yeah. So this is a typical POS session. You can share code. You can, if you write tutorials and you want to share code and allow users to experiment with it, it's a great way to depend on POS for such use cases. You can use it for deeper inspection of databases, data visualization, development of your tools or bots. Basically, just create and share documents that contain live source code. Okay. ToolForge. I mentioned earlier, it's our platform as a service offering. You basically don't have to worry about management of infrastructure. You deploy your code, and the infrastructure takes care of running it. I drew some parallel between this PaaS offering and the ones available on other public cloud platform like AWS, Elastic Beanstalk, or Google Cloud App Engine, or Azure's App Service. If you've used any of those before, then ToolForge might be familiar in the way it expects you to run your code. So the main use case is typical workload for ToolForge is to either run tools or bots, and you can run your tools or your services as either a job or a web service. For a job, it can just be a one-off task you run and execute, or you can schedule it just like a cron job, or it can be something that run continuously. This is all supported. And then for web service, you can create your typical web pages, your REST API, etc. So ToolForge is based on two computing engines. We have a grid engine. This has been deprecated anyway, but by far most of our current tools run on this engine. And then we also have Kubernetes, which is the new standard for containerized workloads. It's a managed service similar to GKE for Google Kubernetes engine for Google Cloud, or Azure Kubernetes service for Azure, or Elastic Kubernetes service for AWS. So if you can run your your containerized workloads on those, you'll find this also familiar. So for ToolForge, we currently don't have a web user console like a Google Cloud Console UI. So you connect to the service via a Bastion host, or typically called a Jam server, using SSH. And from this Bastion server, you can issue commands to the Grid API or the Kubernetes API to deploy your code. So basically, you access ToolForge using a Jam server or a Bastion. So for storage, we use network file sharing. And again, to draw to, to, to to compare with other public cloud platforms, I would say maybe it's similar to cloud storage for Google Cloud, or S3 for AWS, or Azure Storage. You can your user files can be stored there. The files used by your tools can also be stored there, and even your workloads running on Kubernetes can also be stored there. It can also make use of files stored on there. Okay, so this diagram indicates how a typical workflow will look like. You typically SSH into ToolForge Bastion, and then interact with the services like the Grid Engine service or the Kubernetes service, and even the NFS storage. So from the Bastion, there are a set of tools available to you. The kubectl tool is available. The Grid Engine tool, command line tools are available for you to use to manage your workloads. And then another service is also a cloud VPS, which is the foundation's offering of an infrastructure as a service virtual machines. So if you want more control of the underlying infrastructure, then you can request for your own virtual machine, configure it to your liking, and then run your code. Of course, you have to do a bit more work because you are basically customizing the infrastructure that runs your code. And I will also compare the cloud VPS to Google Cloud's compute engine, or Amazon Web Services EC2 instances, or Azure virtual machines. If you've used any of them before, you'll find this familiar. Once they are provisioned, you can SSH into the servers and configure them just like the way you would on any other cloud platform. And unlike ToolForge, we have a web UI that you can use to access your virtual machines or manage your virtual machines. The UI, it's called Horizon. So it's similar to again to Google Cloud Web Console, where you have access to your cloud resources. In this case, virtual machines that you can create or delete them. Yeah. So yeah, of course you can also have access to the instances via SSH on your or through that channel. But then you also have a web UI channel available to you for use. Okay, so this diagram just depicts accessing your virtual machine once it is provisioned. You use SSH through the internet and then have access. From there, you can install the packages you want for your code. Basically, just set it up. Of course, you before you get it, you need to justify the use, what you're going to use it for. It's also available for free. Once it's granted, you can proceed with your work. And then we also have wiki replicas. These are live database replication of the production MySQL or MariaDB databases. But they are sanitized for use, so you can have access to the data for your own experiments, for your own research, or for your own development work. And then we also have I mentioned ToolsDB earlier. So this is again, if I want to do a comparison, it will be similar to Cloud SQL for Google, or RDS for Amazon Web Service, or Azure Database for MySQL. If your tool has a need to store data in a database, you rely on ToolsDB to create those tables and your own custom schema and make use of them via tools. So it's accessible by ToolForge, Cloud VPS. So in summary, let's see some of the other things you can do on this platform. So let me just summarize. You can, anyone with a Wikimania account can sign up for query and then query the database replica. The replica is stripped of personal editor information, but contain all the data you need for your experiment or development or research work. This is also a session for POS we saw earlier. You can run your code experiments. You can depend on existing pre-installed tools there to maintain your wiki. A typical example is a PyWiki bot. You can run that from POS without any installation or overhead on your end. Then on ToolForge, you can run a bot. Either you can run workloads periodically, continuously, or one-off. You have automatic access to database replicas. If the platform as a service offering will not work for your workload, you can of course apply to use Cloud VPS, where you got your own virtual machine instances. Then you have to do your own customization, installation, package installation, and all that. So here are some of the things. Some users have created and are running on cloud Wikimania Cloud Services. We have WikiShootMe. So this tool displays Wikidata items, Wikipedia articles, and common images and coordinates on the same map. And it's very useful for uploading images from articles or Wikidata entries. And then you can see another one called Human Nikki. This is hosted on Cloud VPS, and it provides statistics about gender gap in Wikimedia project content. And then another one, it's X tools. It's just a set of tools and statistics to help editors to get their work done. And it's also hosted on Cloud VPS. And then we also have page views. So it helps you get insights into the amount of traffic you are receiving on your pages for analysis. It's also hosted on ToolForge. And we have Kiwix, the Wikipedia offline reader. So if you've read Wikipedia using an offline reader, the content was probably generated by Kiwix. So Kiwix builds it, and it usually also employs a mixed use of cloud services. And we also have Wikisource exports. So every page in English Wikisource has a link to the sidebar of every English Wikisource page. And it is used to create about 20,000 EPUB of PDF file a week by people who want to read Wikisource book offline. So it helps you effectively download a wiki article, either in EPUB format or PDF format. This is running on Wikimedia Cloud Services. And then we also have Wikidata game. So it's a game that is used to quickly insert properties into Wikidata records. And then we also have, finally, a tool called Deployment Prep. So it's used across the foundation to test changes before releasing to production. Yeah, so those are some samples or a list of tools that are currently being powered by Wikimedia Cloud Services. If you have a need to deploy your code, host your code, that's a service that is available to you. It is free, as long as your use case aligns with the movement's goal. You are good to go. And if you want to create an account, this is the information to create an account on ToolForge. And then for Cloud VPS, you also put in a request. It will be reviewed. Once that is done, you are good to go. Okay. So these are some of the channels you can reach the Cloud Services team. You can reach us on IRC, mailing list, even our tech blog. Those are channels you can reach us through. These are a sample of other technical community resources, from ToolHub to Developer Portal to Small Wiki Toolkits, and then the Wikitech technical documentation sites. So that is it. If there are any Q&As, let me know. I think I just made it in time.